Hello everyone, how are you? I'm fine. Now we are going to do the bit manipulation on ALX. Bit manipulation on ALX. So let's see what is this. We have uh, a two digits byte number A and B here. So the OR operated A and B only the two. That means the A and B should be 0 if A or B to be 0. That means false and false only be false in OR operated, but the other conjunctions should be true. That means 1. In AND operated, only true and true should be true, but the other conjunction should be 0. And the other one, which is XOR operated, XOR operated, is an XOR operated only this is the A and B are the same, the value should be, that means false. Whenever it is A is true and B is true in a sense, it should be false. And A is false and B is false, it is false. That means A and B have the same characters. That means that means identical. If they are opposite, that means true and false or 0 and 1, then makes this one it is true and or it is false. It is 1. The other one, the value in which says that not operated. Not operated, which is means 0 is not. That means if it is false, not false means it is true. If it is false, so that this is the bitwise operations. So now a clear explanation how to do this. As we have seen, all the questions are hexadecimal characters. Hexadecimal anything which is found at the start of the numeric explanation, which is 0x, which is hexadecimal. The other, which is a number in a hexadecimal base. In hexadecimal base, you know that is binary base, octa base, base 10, and base 16, or hexadecimal base. Hexadecimal base. So, what is this? Before this, I will show you how to do it. Before this, all the questions are hexadecimal. So, how to change to base 10 and binary base, binary or decimal. So that I will show you, I have a slide which is shows here, hexadecimal to binary, which is 0 means, 4-digit 0, and 1, this one, 2, 3, 4, 5, 8, 9. It is up to 9, it is the same as in base 10. In base 10 up to 9 it is the same. But once 10 it is, in hexadecimal, 10 means A, 11 means B, 12 means C, D is 13, 14, and 15. So up to 50 it is A is 10, B is 11, C is 13. So they are put as an hexadecimal base. So base hexadecimal numbers changes to binary in this way. The other one, hexadecimal to decimal. When we want to change our hexadecimal values to decimal values, that means, for example, we have 88 with, that means we can write here, we can write this one, that means in base 16, we can write here 0x by removing 16. We can say that. We can say x 0x88. So to change this one, we have to a step followed by this one. First, we write down the hexadecimal number in this format, and then, sorry, and then divided 88 base 10 successfully by 16 until the quotient is 0. That means, let's say 88 divided by 60, which is 5. 5 multiply with 16, it is what? 80, remainder of 8. And then we have 5. 5 divided by 0, we the remainder 0 with the value is 0 and the remainder is 5. So until the quotient is 0, in essence means the value divided by the quotient, 5 divided by 16, is quotient is 0. So the remainder one, this one. So we write from the bottom to the top, from the bottom to the top. So the most significant bit. So the most significant bit is this one, and then 5. So 58. 58. In this way, we change our decimal to what? Hexadecimal. Now let's see this one. Before that, I will show you. So this one, this is in base 16. To change in base 10, which we can write this format. That means 8 multiplied by 60. That means this is 0 and this is 1. So 8 multiplied by 16 to the power of 1 plus 8 times 16 to the power of 0. In this way, the value should be put as in base 10. The value is like this way. So we can change decimal to hexa and this hexa to decimal this way. So now let's do task 1. As we have seen in the task 1, it says that, you see the task 1, 0x, it is value here. So we have to change our computer, our programmer, whatever the program used in a C program, it is read as in byte. So we have to change this value to bytes. We can see that, you see that in base 16, in base 2, so that to change this one, 0, the first number 0 changes to base 2 means 0001. As I have showed you. You see 0 is 0, this one in base. And then 1, this one. So write this one as it is, because the first at the left and the second as the right, and continuously write it. Continuously, it is makes 8 bits. 8 bit. So like this way, and group each value of step 1. Group it. Once this and this makes this one. So the value, this value in binary is means 1. In binary means 1. So to do our value is in binary 1, how to do any programming. Any programming I have to do that we have a value, let's say x is this one and y is this one. So we want to end operated by using an end operated. What is the value of this one? So our program, which is a Visual Studio Code, which writes the result in the form of what you call it decimal, in a decimal way, so that once a decimal you have got, you can change it to hexadecimal and binary. So let's say this is uh, unsigned int x is equal to this one. This value means you see this value, which is changed into a binary format. This is hexadecimal. The binary is this, and this one is the same. And the end operator, we can say that 0 0 means, you see, 0 0 0, because false 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 in end operator, and 0, this one, this, and this one, this one, and this one, and this one. We can continue like this way vertically, this one and this one, which becomes 0, and then the next is 0, and the next is 0, and 0, and 0. We have true and true 1. So the result we have 0 0 1 for binary case. We have got a binary case 0 0 1. What does that mean? This is 0 and this is 0 in hexadecimal case, because I have showed that you see, this is 0, this is 1, this is 1. That means in case of changing binary to hexadecimal. So let's see the result, what is called this one. Let's say save this one, and then we have saved this one. So GCC, let's say clear this one, clear GCC 0, no, say hex.c, because the file which is saved by hex.c, which is changing, that means compiling to the file called hex. Let's say /hex. We have got this one, 1. 1 in a decimal means the same as in a binary. So the result should be this one. It is the same as in hexadecimal. So the second, we have this one, question number 2. You see, this is 88 in base hexadecimal, and this one is also in base hexadecimal. How to say that? Let's say I have wrote the question here. That means 88 means 8 means 0 0 0 1 8 1, and then the other 8, this one, and we have 0 1. So we use end operated. This is the value, end operated. What is the result? You see, end operated means we can say that 1 0 in end operated 0 0 0 0 0 0 0 0 0 0, and then 0, and then 0, and then 0, and then 0. So the value is, what do you call it? 0. we can say that the value is zero. The value is zero. Or we can show you how to the program is written here. We have a program and then an assigned R here. R is int X and R. Y. So the result should be, let's say, Control S and then GCC question number 1 dot C, let's say Q1, I can say this one, and then dot slash Q1. Yeah, you see, zero. Zero in essence in hexadecimal, in a decimal zero is the same as hexadecimal zero, and a binary zero as the same. So the value is zero. So let's see the second question. Question number 2. You see, we have this value. We have this value. First, we have to change this value to a binary. A binary. So to change the binary, first the 4 and the second 4. And the same as this one. So how to change it there? I have changed here. We have the value 44 means the 4. This is the 4 one. This value is for this one. And this value is for this 4. And the same as 22 in a hexadecimal, the same as this one. So once we use AND operated, you see what it says that? It is OR operated. So in OR operated, we can say this is not OR operated. So in OR operated, we have written here. So in OR operated, that means, let's say 0, 0 means 0, 1, 0 in OR operated, 1, 0, 1, 1, 0, 0, 0, and 0, 0, 0, and 1, 0, 0, and 1, 1, and then 0. So the result of this one in base 60 means this is the first value and this is the second value to write in base 60. That means this is, you see, this is 0, 1 multiplied 2, you see, to the power of 1 and to the power of 2. That means this is 6. This also 6. You see? This is 6. This is 6. So it is 66. 66. So what is 66 in base 10? That means 66 of 66 of in 66 in hexadecimal to change into binary. That means the decimal way. We can say like this way. Let's say Control S and then GCC Q number 2 report Q2.C Q2. Now let's say GCC Q2.C. Let's say Control S. GCC Q2 dot C. I said I write here 0. No, it must be O. So Q2. Now it is okay. Now just dot slash Q2. You see 102. So 102 in base 10. So we have to change this 110 to in base 16. That means when divided by this one by 60, we can get 6 and a remainder of 6. That means 6 multiplied by 1. I have wrote in here, maybe on the PowerPoint. You see, in base 68, 88 change into the base for question number 2. For question number 2, we have 44. The value is here, and 22. The value is here, and then we get this value. So as I show you here in base 10, that means we have 66. That means no. 102. We have vacant. How to get this one? And then 102. Now let's say 102 divided by 16, which is 6, and a remainder of 6. That means 6 multiplied by 16, it is 90. What? 96? 96 minus 102 minus 96, it is remainder of 6. And then 6 divided by 16, remainder of 0, and that means the value quotient is 0 and the remainder is 6. So the value is 66. The value makes 66. Here it is, we can say that 66. In this format, we can change. Or I will have show you that you can change. You can write here. This is one value 6 and the other value 6. So the value is 66 in base what? In base hexadecimal. In base hexadecimal. So the value is 66. Now let's do this. This is this is this, or operator. That means 1 to 0. The value is this one. It is simple. For question number 4, we have a question number 4. Let's say question number 3. You can see that here the value, how it is coming. That means this is the OR operator, 0, 0, 0, 0, and then 0, and then 0, and then 0, and then 0, because it is an AND operated. Once the value, we can say that this is an AND operated. An AND operated. We can say an AND operated. Control S means it shows. You see, an OR operated. Yeah, an OR operated. Sorry. An operated. It becomes 1 because 1 0 it is here. So I have to make it this one, and then Control plus S, and then I have say QB3, GCC, Q3.C minus O, Q3, enter, Let's say Q3, sorry, dot slash Q3, enter the value is 1. That means the same as in hexadecimal. The decimal 1 means the same as in hexadecimal in the binary. So the result is the same. For number 4, we have 89 in hexadecimal. So in binary means 8 means, you see the first 8 means this one means this one, and 9 means this one. Sorry, 0, 1, this one. So to change, that means this is the right operator. The right operator means this is cancel out, and this is the first one, and the second, and the fourth, and the third. The next 3 values has to be filled by 0. Has to be filled by 0. That means, let's say this one, let's say cancel this one, delete this one. How it cases? Let's say this 3 come to this value, and then 1, and then the next we have 0, 0, 0. So this value is left. You see it like this way. So we can write, you see, 1, because the 3 has to be cancelled, and then I have to write this one, Ctrl C, and then paste here. So 0, 0, 0, and then we back this one. Now you can see that. You can see this is cancelled, and then space here. Yeah, you see this value is this one because we cancelled the last 3 digits and shift the remaining values to the right. The remaining values to the right. That means the same. The remaining value to the right, like this way, and this is cancelled out, and we have a vacant space, this one. Then we should write the values as 0. The values are 0. This is what. So we can say that what is the value of this one? This is 1, this is 0, this is 0, 1, 2, 3, 4. So 1 times to the power of 4, it is 16, 16 plus 1, that is 17. So 17 it is any, what? The value 17, what does it mean? Let's say Control plus S, you see Control plus S. So GCC Q4 dot C Q4, enter. Let's say Q4, the value is 17. The value 70, which is this one. So how to write in base 16? We can say that this value means, you see, 1. This value is 1. What about this one? This value is 1. So 1, 1. We can write this one. 1, 1. 0x 1, 1 in a sense. 0x 1, 1. This value shows that 0x 1, 1. we can write this one. This is the value which is shows that this one. So we can say the value it is this one. And the third, this one, we have to change this one into a binary and shift to the right. The last one, delete, and then add to the left vacant space with 0. Left vacant space 0. This is the one. I have shown that the result, which is this one. You see, this is we have, and once we cancel this one, because it is the left operator by 1, the right operator by 1, so we cancel this one, we have got, you see, 0 0, and then 0 0 0 1 we have left. This was vacant. Once we cancel this one, so we should substitute the vacant space with 0. So we have got one value. It was, this is 2. Yeah, this is 2. So the result here I show you is the result of this one is this one. And then this one, you see, we have 1/3. What does that mean? This means we have a value, you see, Control S, you see the value 1 means this one, 3 means this one, and then right operator. That means delete this one and shift the remainder values to the left. Once we have a vacant space to the right, we should fill with 0. So the value is 0 0. This 0. We can write. We can copy this one. Control C, and then V, and then this 0 is coming through here. This, and then this is cancelled, and then we have a vacant space 0. So we should fill this one 0. You see, which is equal to what does that mean in base 16? You see, this is 2, yeah, 0 0 x. This is 2. This is what? This is 2 plus 4, 6. 26 in essence. 26. What does that mean? 26 in base. What does that mean in base? In decimal base? What means base 10? We can say the Control S. Control Z, and then Control S. We have to save it, and then GCC Q6.c 0 Q6 enter ./Q6, we have the value 38. Once 38 divided by 16, we have 32, we have left 6, 6 divided by 16, the quotient is 0, the remainder is 6, and we write from bottom to top. We have 2. We have 2s here. 2, we have get 2, the remainder of 6, and 2 divided by 16, it is 0, and the remainder of 6, then the remainder of 2, and the value should be 26. The value should be 26. So let's 26, you have 26 here. And then this one, left operator to 1, makes this one 2, yeah? Makes this one 2. It is simple, by the way, it is simple. You can change this by 16. So we should divide this one by 16, and we have what, 6 times, and we have got 96, 96, 98 minus 6, 96. We have got 2, 2 divided by 16. The remainder of the quotient is 0, the remainder is 2, and then 62. 62, this one, the value is this one. You can see here. And then we have an OR operated, so 1, 1, 1. So it is the same. It is in base 2. You can change it to in base 2. The value is this one. And then the question number 10. We have this value and operated. So we get this one. So because all these are 0 and there is 1 only here. If there is 1 here, we have got another true value. So this is this one. Because in AND operated, only true and true are valid true. The other one, we have this value. Question number 11. I have question number 11. So let's say this one, question number 11. Question number 11, what says that we have 0, 1, 2 in hexadecimal. That means this is 1 and this is 2. This is 2. So to change not operated of this value become this 0 not operated of once not operated, use 1 0 1 0 1 1 0 0 1 1 0 1 1 0 and 0 is 1. This is a value. So what is this value? This value means, you see, 1 2 3 3 to the power of 3 plus to the power of 2 plus to the power of 1, which is 8 plus 4 plus 2, which is 14. 14 means, you can see here, 14 means you know 14 means this one. This is 10 11 12 13 14. 14 means E. 14 means E. And then this one is 13 E. That means this one, the sum is 13 and the value should be E. So D, that means ED. ED. This is E, this is D. This is E, this is D. But the value which is calculated here in C, it is minus 91. It is an extra explanation for this value which is given in this result. So the value of this one is ED. ED when changing this one. And the other one, which is this one, in percent of this one, and the value is this one. How it is coming? Let's say 12. Just see. We have 98 this one, 89 value, and then we have this value. We have an AND operated, only true and true are true. This is at the first one, so the value is what? 0 0 0 0 0 0 and 0 and then 1 1. This value should be what? The same as hexadecimal, which is this one. This value is this one in AND operated. So this is this one. And the second, we have a byte operator. This means all B means a Boolean expression in a byte form, in a by base 2 in a sense means base 2. So we should divide this one into 4. This is 1 and then this is 1. So the first, this one means this is 1, this is 2, 2 raised 2 plus 2 raised 1. This is what? 2 raised 2 means 4. 2 raised 2 means 6. 2. 4 plus 2, 6. The first one, 6. And then this one, this is 1 plus this is 8. This is 4. 8 plus 4 plus 1, which means, I think, 13. 13 means D, 6D. The value is 6D. The other one, we have this value. So now we have this value. Let's say in a programming, in a video studio, we have, I think, this one. We have 66. You see, 66 means 6 this one, and then 6 this is 1. And changing to, we have 22. This is 2. 22. This is 2. So we have used an AND operator. So in AND operator, we use 1, 1, only 1. You see, so that we have 0, we have 0, we have 1, because 1, 1 is here, and then 0, and then 0, and then 0, and then 1, sorry, 1, and then 0. So what is the value here? What is the value here? We have got the value here. It is, you see, x 0, 22. This is the same as, this value is the same as this one. The same as you. So the value is this one. Simply. So in the program, we can say, we can control S. So let's say GCC Q12, I think Q14, yeah, Q14 dot C, Q14 dot slash Q14. We have got 36. Once we have to 36 divided by 16, 2, remainder of 2, and 2 divided by 16, 0, remainder of 2. Once we write this one, 22. So the value is 22. So now the value is this one. And then the question number, this one, you see, we have a base 2, and then changing to base 3, 16, base 10. We have presentation here. You see, we have a number to change into base 10. So divided by 2, we have 49. We have the value 0, and then divided, and then divided, and then divided. So we should write the remainder 1 from the bottom to the top. The bottom to the top. The value here, it is 110010. So the value is, here it is, this one. So to change this one into also in base 10, we should multiply this value 0, 1, 0, 0, 1, 0, 1. So that for 0, it is a value 0, 1, 1. This is 2, 3, 4, 5, 6. 6 is the power of, to the power of 6. 64 plus to the power of 4, which is 16 plus 2. The value is 82. 82. 36, 62, 64 plus 16 plus 2 is this one. And then we have shown that this one, this is divided by 2, and then continue the axis way. The value is this one. The value is this one. The other, which is this one, I have a program here for 70. So we have a 17 means 98 in base 2 is this one. For 9, 9 means this one. 8, 8 means this one. 1, 0, 0, and 0. And then we want to not operator. So for 1, the not operator is 0. For 0 is 1. For 0 is 1. For 1 is 0. And then for 1 is 0. And then 1. And then 1. And then 1. So the value, what does that mean? In base. What? The answer, the question is in base 16. So in base 16, the value should be, this is 2 plus 4, 2 plus 4, 6, 6, and this one is 7, 67, which is 0x67, which is equal to 0x67. So the answer is 0x67. And remember, this is the value 89, which is changed into base 2. Base 2. You can see that you can change it to this one and then go to 8 means, 8 means 1000, 1000. 9 means 1001. This is the answer. And this one, how to change this one to base 10? Yeah, I have shown you how to change this one. This is the value 137. Let's check the answer. Yeah, all the questions are answered. Thank you for watching. Thank you for watching. This is an important explanation to understand how to do base 16 into binary and decimals.